So, as mentioned in class, we're going to be starting solutions. I know we have not taken the unit test on gas laws yet. We will do that next week after accreditation. But solutions isn't too complicated, so we'll go ahead and get started with that now. The video today will cover pages 401 through 406 of the book. So, first of all, what is a solution? Well, as we talked about in class today, a solution is going to be a homogeneous mixture of two or more substances. You'll recall that homogeneous means when you look at it, it looks all the same. There's no lumps, there's no clumps. It just looks consistent. It looks the same, even though it's not just one pure substance. There's going to be at least two things. There's going to be the solvent. That's typically the thing you're going to have the most of. It's the thing that does the dissolving. And a solute, the thing that is dissolved. Sorry for the announcements in the bell. I'm trying to get this out to you before I leave school today. For some examples of solutions, we can turn to page 402 of the book. There's a whole chart there. Looks something like this. You can have a gas dissolved in a gas, a solid dissolved in a liquid. What we're going to be doing is typically solids in liquids and liquids in liquids in class. But there's many different things you can do, and we will, in fact, next time be taking a look at some examples of solutions. Common solvents, well, the most common solvent that we're going to be working with is water. Water is often called the universal solvent because many things will dissolve in it. It's not truly universal. There are some things that won't dissolve because really the most common thing to think of when you're thinking of dissolving, think like dissolves like. Like dissolves like. So what this means is that a polar solvent can dissolve polar solutes. So water will be able to dissolve things that are polar. And you'll remember that polar means they have charges on them. So water can very easily dissolve ionic things, plus large covalently linked things that have charges on them, but not so well other things. You may have heard the term water and oil don't mix. Oil is nonpolar, so to dissolve oil, you would need a non-polar solvent. And there are some of those, and we will discuss those as well. Common solutes. Really, almost anything that's small enough can be dissolved into a solution. We can essentially, for our purposes, divide these up into ionic and covalent. Ionic solutes dissolve very easily in water, and when this happens, they can conduct electricity, so they are called electrolytes. You will have seen this in the lab that we did last time. The salt was able to conduct electricity when it's in the liquid form. Salt won't do that when it's in a solid form, only if it's in liquid form or dissolved in a liquid. Oftentimes, when ionic compounds dissolve, it's accompanied by a change in temperature because there's a certain amount of energy needed to break the attraction of the sodium to the chloride. Covalent solutes, well, they're usually non-electrolytes. Sugar, for example, you'll have noticed it did not conduct electricity. Usually, in the cases of acids, we can have some covalent things that will break apart in water and therefore be able to conduct electricity. Next time in class, we'll take a very close look at the microscopic difference between ionic and covalent substances dissolving. Couple of variations on solutions, because solutions is a rather general term. A suspension. A suspension is very similar to a solution, except the particles are so large they will settle out. Think muddy water scooped up from a river. The larger particles of sediment will settle out. You can shake it up and get them to resuspend again, but they'll still settle out. So it's not truly a solution. Also, a suspension can be separated by a filter. You can filter out that muddy water, the mud will be left behind, the water will go through. There's another sort of mixture that's very similar to a solution that's called a colloid. The solute particles in a colloid will stay suspended. They will stay in the liquid. They won't settle out like in a suspension. But it's not quite a solution yet. The solute particles are sort of in between. Some interesting properties here are the Tyndall effect. Tyndall effect means when you shine light through a solution, like a laser light, the light will go straight through. If you shine a laser light through a colloid, the light will scatter out. That's a common way of telling the difference between a colloid and a solution. Page 404 of your book has an example of some common colloids. Fog would be one, as well as salad dressing. In salad dressing, you've got oil and water mixed together, but the particles are kept from separated by something called an emulsifier. That's going to be an egg in the case of many salad dressings. That's going to do it for today. Please bring those charts that we did in the lab with you to class next time so that we can discuss your findings.